In this video, I will teach you how to find the equation of a slant asymptote of a rational function. And we will review how to find horizontal asymptotes, vertical asymptotes, and holes. This is AP Pre-Calculus topic 1.11. If you appreciate this content, please hit that like button. In a previous lesson, we learned that given a rational function, if the degree of the numerator is 1 greater than the degree of the denominator, then the rational function has a slant asymptote, where the asymptote is a diagonal line like this. The function k of x, graphed above, has a hole at x equals 2. You can see that because these factors cancel out. And a vertical asymptote at x equals negative 1. You see that from this factor in the denominator that does not cancel out. When the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote, as you can see. But because the degree of the numerator is exactly 1 more than the denominator, we have a slant asymptote. Now the slant asymptote turns out to be y equals x plus 1. But how do we find that? To find the slant asymptote, we use a process called long division. And it's just like the process we might use to divide 676 by 21 by hand. We would set it up like this. We would look at the first number 2 and then the first number 6. How many times does 2 go into 6? 3 times. So we might put a 3 up here, and then we would turn and multiply that 3 times 21. 3 times 21 is 63. So we would bring down the 63, and then we would subtract. Except for really it's like there's a 0 here, and we're subtracting 630. Anyway, that leaves 46. And then we sort of start over. How many times does 2 go into 4? 2 times. So we put a 2 up here. Now we take that 2 and we multiply. 2 times 21 is 42. So we put that 42 and then we subtract again. We get a remainder of 4. And what we do with the remainder is we add it on to the end, but we put 4 over 21. So we could say the quotient is 32 with a remainder of 4, and we would write the answer, as I said, 32 plus 4 over 21. The same process works for polynomials. If I want to divide this trinomial by this binomial, I set it up like this. I first look at the 2x and the 6x squared. Then I ask myself, 6x squared divided by 2x is what? Well, that would be 3x. Think 2x times 3x makes 6x squared. Anyway, then you take the 3x and you multiply it times 2x plus 1. Distribute. So that will give us, of course, the 6x squared that we targeted, but also 3x times 1 is 3x, which goes like this. But then you subtract. 6x squared minus 6x squared is 0, so that's gone. But then 7x minus 3x is 4x. And we still have the 6, so that comes down. Then we sort of start over. How many times does 2x go into 4x? Well, that is twice. Then you turn around and distribute. 2 times 2x is 4x, and 2 times 1 is 2. Once again, you subtract. The 4x cancels out, and we are left with 6 minus 2, which is 4. The fact that we have already reached the constant at the end of the quotient means that this is the remainder. And just like before, we would do plus the remainder over the divisor. So that's the answer. In other words, the quotient was 3x plus 2 with a remainder of 4, but the answer is 3x plus 2 plus 4 over 2x plus 1. The quotient, this part right here, turns out to be the slant asymptote. Example 6. Let h of x equal this. Use long division to find an equation for the slant asymptote of h of x. Put your numerator on the inside and the denominator on the outside. Start by dividing the leading term of the dividend by the leading term of the divisor. So 2x times 3x will make 6x squared. So put your 3x up here. Then multiply. Distribute the 3x across the 2x plus 1. 3x times 2x is 6x squared. 3x times 1 is 3x. Then you subtract this. The 6x squared cancels out. X minus 3x is negative 2x. And you still have the plus 5, so bring that down. Start over. Negative 2x divided by 2x is what? Well, that's negative 1. Now multiply. Distribute the negative 1 across the 2x plus 1. Negative 1 times 2x is negative 2x. These should always match. And then negative 1 times positive 1 is negative 1. Then you subtract. Negative 2x minus negative 2x is negative 2x plus 2x, which is 0. So they cancel out, of course. 5 minus negative 1 is really 5 plus 1, which is 6. We have already reached the constant, so this is the remainder. So the answer is going to be 3x minus 1 plus 6 over 2x plus 1. However, only this part is the slant asymptote. The slant asymptote is y equals 3x minus 1. For example 7, we need to find the equations of any asymptotes of g of x. But first we need to write g of x in factored form. Noticing that every term of the numerator has an x in it, let's take out a common factor of x. So that will be x times x squared plus 4x minus 12. Now we can write g of x in factored form by factoring the numerator the rest of the way. So we have x times binomial times binomial. X squared will be x times x. 12. 12 will either factor as 3 times 4, or 2 times 6, or 1 times 12. But inner plus outer must equal the middle of 4x. So let's use the 2 times 6. To get a middle of positive 4x, we need the inner to be negative 2x and the outer to be positive 6x. Now let's factor the denominator. X times x makes x squared. The 6 will either factor as 2 times 3 or 1 times 6. But inner plus outer must equal a middle of positive 7. So let's go with the 1 times 6 option. So in order to make a positive 7x middle, we need a positive 1x inner and a positive 6x outer. They didn't ask us for it, but we can see that there will be a hole at x equals negative 6 because of the way these factors cancel out. I like to identify that first because it makes it easier to see vertical asymptotes and such. So we have a vertical asymptote at x equals negative 1 because we have this factor in the denominator that does not cancel out. We have learned that when the degree of the numerator is greater than the degree of the denominator, there will be no horizontal asymptote. When the degree of the numerator is exactly 1 more than the denominator, there will be a slant asymptote, and we just learned how to find it. Let's do long division off to the side. Put the numerator on the inside and the denominator in the front. To figure out what goes in the top first, take the leading term of the inside polynomial and divide that by the leading term of the outside polynomial. So x to the third power divided by x squared is x. So I encourage you to put that lined up with its like term. So I'm going to put the x right here. You might want to add a placeholder here. There's no constant, but let's put a constant of 0 on the end, just as a placeholder. So you take your x and you distribute. X times x squared is x to the third power. These will always match. X times 7x is 7x squared. And x times 6 is 6x. Then you subtract all of this. These cancel out. 4x squared minus 7x squared is negative 3x squared. Negative 12 minus 6 is negative 18x. And I think I'll just bring down our placeholder. We sort of start over now. Take this leading term divided by this leading term. Negative 3x squared divided by x squared is negative 3. So that's what comes next. Now you multiply. Negative 3 distribute across the trinomial. So negative 3 times x squared is negative 3x squared. Of course, these always will match. Negative 3 times 7x is negative 21x. And negative 3 times 6 is negative 18. And then you subtract. And these will cancel out. But then we have negative 18x minus negative 21x. So negative 18x plus 21x is 3x. 0 minus negative 18 is 18. It's really 0 plus 18. This is the remainder, we know, because we've already reached the constant. And guess what? This quotient on the top gives us the slant asymptote. Y equals x minus 3, which we can go ahead and put right here. Example 8. Let d of x equal this expression. Which of the following about the graph of d of x is correct? Before we look at the options, first of all, let's factor the denominator, so we have this. Notice that the x minus 1 factor in the numerator and the denominator will cancel out. However, because a factor of x minus 1 still remains in the denominator, we have a vertical asymptote at x equals 1, not a hole. There are no holes because there's no factor in the denominator that completely canceled out. These canceled out, but that x minus 1 is still there, so no hole. To figure out whether d of x has a horizontal asymptote or a slant asymptote, we need to compare the degrees of the leading terms. So in the denominator, we can just see that the leading term is x squared. For the numerator, we need to multiply this out without these constants of plus 4 and minus 1. So 2x times x times x. That is 2x to the third power. We see that the degree of the numerator is greater, so there is no horizontal asymptote. Because the degree of the numerator is exactly 1 more than the denominator, there is a slant asymptote. We don't know exactly what it is, but we know it exists. This should be enough to answer the question. So option A, the graph of d of x has 1 horizontal asymptote. Well, that one's out. Moving on to B, the graph of d of x has 1 horizontal asymptote. Nope. The graph of d of x has 1 slant asymptote. Go on. 1 hole. Nope, there are no holes. Alright, hopefully D is it, because This is our last option. The graph of d of x has one slant asymptote, no holes, and one vertical asymptote. Well, that's exactly what we found. So the answer is D. Example 9. Sketch a picture of the rational function f of x with the following properties. Condition 1. The limit as x approaches infinity of f of x is negative infinity. In other words, as we go to the right, the value of the function falls. So we need to have this type of end behavior. Number 2. The limit as x approaches negative infinity of f of x is positive infinity. So as we go to the left, the function rises. So the end behavior on the left has to be like this. The limit as x approaches negative 1 from the left of f of x is negative infinity. So that means there must be a vertical asymptote at negative 1, and as we approach this vertical asymptote from the left, f of x is going towards negative infinity. So that means it must be doing something like this. And then number 4, the limit as x approaches negative 1 from the right is also negative infinity. So coming from this side, the graph is again approaching negative infinity. So sort of connecting these up to make a possible graph. Here's one possible solution. There are many solutions, so don't just copy me, make your own graph. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.